Section 2.3, section 2.3. Composite functions. That's a pin. I better not write with that on my active panel. Composite functions. Given two functions, we'll call them f of x and g of x. The composite function of f and g will convert x into f of g of x, or g of f of x, depending on which order you want to compose these functions. The neat thing about functions is, not only can you add, subtract, multiply, and divide them, and the result will be another function, you can also plug a function into a function which will result in a function. And I know I said the word function a lot, but that's because functions are a closed space in mathematics. Anytime you do something with a function, the result is a function. It can't exit that space. So it's really neat. Now, there are other ways of writing f of g of x. That one's my favorite, with the g of x inside the parentheses that you see up there in the sentence. That's my favorite form. I like that one the best because it really makes it obvious, oh, I am plugging g of x into f of x. But the other way that it could be written is fog x. The little o literally stands for of. Or the one that IB likes to use, because I think they just like being, like tip their beret kind of people, is f of g such that x maps onto f of g of x. All that craziness, it just tells you that if you plug in x, your output is an f of g of x. That's all it says. Okay, but it all means you just take g of x and plug it into f of x. And I told you could compose them in either order. You could do f of g of x, or you could do g of f of x. But in general, and this is in general, meaning it's not a 100% thing, in general, f of g of x will not be the same as g of f of x. Are there times when it's the same? Yes, but they're not incredibly common. I may have assigned you a homework question where you had to solve for some values that made it true. Pretty sure I did that. Where like you had to do f of g of x and it has extra letters in it. Then you have to do g of f of x with extra letters. And then it says for what values of a, let's just say, would the compositions be equal? So it's one of those kinds of things. And I've never done the question, so I'm looking forward to people asking me how to do it on Monday. That way I have a chance to do it. So I'm not going to do homework for fun. So look, here's what I was talking about. IB loves to give you this crap. It says given f such that x maps onto 2x plus 1, that just means f of x is 2x plus 1. And g of x is 3 minus 4 of x, or 4x, excuse me, not 4 of x, 4x. Find in simplest form. And simplest means, yeah, you are going to have to distribute and combine like terms and things like that. Okay. So part A, A, try again. I don't want to write it like that. I'm going to write it like this because it allows me to change colors and show that I am going to be plugging g of x into f of x, and I will plug in g of x as a red thing. Whenever you fill the parentheses of f of x with anything other than x, what you want to do is you want to go to f, and everywhere where it had an x, you're going to open a set of parentheses. I mean, if I told you what's f of 5, wouldn't you plug 5 in for x? See, I'm plugging in for x. I'm going to replace x with g of x. And this is showing more work than I would normally do, but I'm just going to do it just to make sure that we're all on the same page here. It says, hey, whatever g of x is, it goes right there. And it's defined. What is g of x? G of x is 3 minus 4x. That's what it is. Again, I'm showing more work than I normally would, but it's good notes. You need a distributor too. 6 minus 8x plus 1. So f of g of x becomes, and I am going to write it in standard form, negative 8x plus 7. Ta-da! So how about that? You plug a straight line into another straight line, and the result is a straight line. Now the real question is, what does that do to the graph? I wonder if the graphs are related in any way. That sounds like a good IA topic to me. Next year. Now B says, no, like IAs are next year. B says do the same crap just in the other order. Okay, well, g of f of x. And I like writing it like that because then it allows me to say everywhere that g had an x, I'm going to put a set of parentheses. and fill those parentheses with that red f of x. And f of x was 2x plus 1. What number am I distributing? Not 4, negative 4. Be careful. Don't let your algebra 1 get you. We are distributing negative 4. So 3 minus 8x minus 4. So g of f of x is, and in standard form, negative 8x minus 1. Hey, look at that. Those two compositions are parallel lines. I actually don't know if that is a pattern or if that is a coincidence, or if that would extend to polynomials of higher degree. Sounds like a good IA topic to me. I'm going to nerd out and I'm going to research that myself. But what do you think?
I think it's just a coincidence because it's just a 2 and a 4 on both sides. That's it.
Because it's a 2 and a 4?
Yeah.
Well, we would have to find out, wouldn't we? See? We don't know until we try more examples. Okay. Next. Well, now I have f of x is 6x minus 5, which is a straight line, and g of x is x squared plus x. This is a parabola. We've been asked to find g of f of negative 1. You have two different ways that you could do this. You could do what we did in the questions before, and you could find out what g of f of x is, and then you could plug in negative 1. Or you could just plug the negative 1 into f, see what you get, and then plug that number in to g. They're both the same answer, and IB gives full credit for both. It really is up to you which you would choose. To be honest with you, I think it's easier to just plug the numbers in and not plug the functions in. All right, but that's a me thing, so that's the way I want to do that. So for A, I'm going to do g of, and you see I'm going to use this symbol instead of the other one because I don't like the other one, f of negative 1. Well, I need to know what f of negative 1 is, don't I? Okay, let's see what f of negative 1 is. F of negative 1 is take your f, and everywhere you saw an x, drop a negative 1. So g of f of negative 1 is the same thing as saying g of negative 11. Come on, panel. There we go. Oh my gosh. Why? There. So I evaluated what is f of negative 1. I got negative 11. Now I'm going to drop negative 11 in to g. So everywhere g had a set of parentheses, an x, oh my gosh, I put a set of parentheses. And that's where I'm going to plop that negative 11. And I'm going to ask that you remember that when you square a negative number, you get a positive number. 1, 2, 1. These parentheses over here don't matter. Minus 11 gives me 110. Cool. Kind of a big number, but whatever. Comfortable with that? So far, so good? No questions, please. You got them. You ask them. Okay. B, f of 0. You ever thought about composing a function with itself?
No.
We heard you like to f of x, so we put f of x in your f of x so you could f while you f.
That's not
No?
times the f, but
Ah,
f squared.
so you're thinking of f squared, right?
What?
But it's not f of x times f of x, is it?
No.
So what Luca has just stumbled onto is that f of x quantity squared does not equal f of x. And you know what's really, really crazy? In mathematics, do you know how mathematicians would write f of x? See, no mathematician would write f of x. A mathematician would write this. And that tells us f of x. Ha! Have you ever wondered why this stands for inverse and that it's not an exponent? You haven't?
I mean, I have.
You've always wondered that, right? It's actually because that superscript for that f is describing compositions. It's describing compositions. So think of it like this. Think of it like this. F of x. Couldn't you technically say that its superscript is a 1? And what do 1 and -1 do with each other? They cancel each other out, which would leave you just an x. You see, that inverse notation is not an exponent. It's describing compositions of mathematics, of functions. So if you write f2 of x, you're saying f of x. So it's actually pretty neat stuff. Yeah. No, God, no. Don't write any of that down. But Luca said something really interesting, so I thought I'd teach you about it real quick. Oh, and you want to see something even cooler?
No.
This, wait. This also means something completely different.
Because wouldn't that imply that you are squaring it?
No, that means the second derivative of x. And we will do that towards the end of this year. It won't look like that, but that's what it means. I know, right? It's crazy, all these symbols. Anyway, now that I've nerded for a second, f of 0. B. f of 0. That means plug 0 into f and see what you get. It gives me 6 times 0 minus 5. That gives me -5, right? So f of 0 is -5, which is all in red, because I plugged in 0 right there. So the original question was actually saying, what is f of -5? That's what it was actually saying. Which would be 6 times -5 minus 5 should be -35.
Could you use your good old graph theory or quadratic theory to answer some of the questions you might have about the interceptions that are with this being f of 0 equals
With the composition type stuff? I don't know. I honestly don't know. And that's why I said it would make a good IA topic. Exploring graph theory, composition theory. It's actually called set theory. It's a very complex form of mathematics. It's kind of like how I was talking to Zach about topology. It's like, or intro to algebra. In mathematics, technically, a lot of times you find that the the smaller the name of the stuff, the scarier the stuff is.
Because to me, I think f of 0 equals -5. I think it's like a line.
Yeah, I think, but so it was a little bit of a coincidence, I think, this time, because it's linear. Because it's linear.
Right.
Yeah, but if it wasn't linear, what would that mean? Yes, ma'am. What?
Like instead of f of x of 0,
Uh-huh.
what if it was f of f?
They mean the same thing. That's why I wrote it like that.
I mean, wait. Or like. Okay, yeah.
You sure? If it formulates itself in a different way, feel free to ask. Okay. Is that it for that page?
Yeah.
Cool. Let's hit the next one. All right. So in this unit we talked about domains of functions, right? We talked about domains of functions, correct?
Yeah.
And domains of rational functions, yes? Great. And now that we've talked about compositions of functions and we realize that compositions are also functions, now we get to talk about domains of compositions. The domain of the composite of two functions depends on the domain of the original functions. Duh. Let me ask you a question. If I had a bag, and this bag could hold, let's say I have 2 bags, okay? This bag has 2 pounds of mulch. My second bag has 1 pound of mulch. Now both these bags are full, right? This is a full bag. I got a full bag with 2 pounds of mulch in it, so it's obviously the bigger bag. And I've got a full bag with 1 pound of mulch. Now you have an empty 1 pound bag. I attempt to pour all of my mulch into your bag. All of my mulch. what happened is a bunch of mulch hit the ground, right? The reason why a bunch of mulch hit the ground is because your bag was more restrictive than my big bag. Basically, I could only hand you the one small bag, correct? The rest of it was wasted. That's because the smaller amount was more restrictive. When you compose two functions, those two functions had their own domains. They may or may not have been restricted, but the more restrictive domain will generally be the boss of the composition. Here's what I'm getting at. Let's say I plug in, I have a polynomial whose domain is all real numbers, and then I plug in a square root function into it. The square root function had a restricted domain, because square root functions always do. When you plug it into the polynomial, even if the radical cancels, the domain is still restricted. You always have to listen to the more restrictive thing, because if you don't, you could get in trouble. It's kind of like how you ask Dad, can I stay out late tonight? And he says, no. So then you go ask Mom, and she goes, sure. Now, if you stay home, you're not going to get in trouble. But if you stay out late, you're going to get in trouble. You're not going to be able to use the excuse that one of you told me yes. You're still going to get in trouble, right? But this works the same way. For example, let's talk about x squared. Hey, look, a polynomial whose domain is all real numbers. And g of x, hey, look, a radical, almost like I knew it was going to be in my notes. Its domain is x is less than or greater than or equal to 0, because you can't take the square root of a negative number. Now, if you compose these functions, f of g of x, what you're going to get is the square root of x quantity squared. Now, I know that simplifies to x. I know this. But you have knowledge of what it was before you simplified it. Right here at that blue underline, its domain is still x is greater than or equal to 0. So even though it simplifies to y equals x, it still has a restricted domain of, oh, but by the way, x is greater than or equal to 0, because the restriction is still there. Here's what it boils down to. When you compose functions, the domain cannot get bigger. It could get smaller, but it cannot get bigger. It could stay the same. It can't get bigger. Restrictions don't go away. So here I have an f of x and I have a g of x. I'm hoping you can see that they both have their own domain restrictions. So before I either do either one of these, I want to know the domain of f of x. Well, the domain for f of x, it's a radical, correct? The rules of a radical is whatever is underneath the square root bar must be greater than or equal to 0. Where are you supposed to be, Carlos?
Lunch.
Go to lunch, Carlos.
Can I get a charger?
For what? What? How so? Where's your phone going to charge?
In my class.
No, you can't do that. You can't, because I need it for my students. Sorry, Carlos. That's for my students. Yeah. All right. So we get x by itself. Here's what you know. X has to be greater than or equal to 5. That is the domain of f. Cool? We good with that idea? Okay. And
Wait,
yes?
is it greater than or equal to 0 because it's under the radical?
Yes, because you can't take the square root of a negative number. You can take the square root of 0, though. So whatever's underneath the radical has to be 0 or bigger always. And you just set the inside to greater than or equal to 0, and you get x by itself, and that will always tell you the domain of a radical, a standalone radical. Now, there could be more restrictions, but for now, we got that. Now, if the domain for g of x, here's what you have to know about g of x. It's a fraction. Fractions have one really important rule. What is that really important rule? Denominator can't be 0. So all that matters for a fraction is that the bottom doesn't equal 0. You need x squared to not be equal to 0. You cannot divide by 0. So solve, quote unquote, solve for x. You take the square root of both sides, Hey, do you guys remember what happens when you cancel a square with a square root? A plus or minus has to happen. So technically the end thing is that x cannot be plus or minus 0, which doesn't really make any sense. So x can't be 0. 0 is neither even nor odd, just like it is neither positive nor negative. There. Part A. Part A has asked us to find g of f of x. A. That's a g again. A. G of f of x. That means take your function g, and wherever you had an x, put a set of parentheses. There was an x there at the bottom of g, and f is the square root of x minus 5. Of course, you're going to clean it up, right? You're going to clean it up. The square and the square root cancel each other. That does not create a plus or minus in that order. It's only plus or minus when you cancel the square with the radical, not the other way around. It's a one-way street. This simplifies to 1 over x minus 5. The resultant function has its own domain. What are the rules of the simplified version of this function? The domain says x can't be 5. Because if it was 5, you'd be divided by 0, right? But what you're supposed to do is look at the domain before you simplify. You just told me x can't be 5. But wasn't 5 part of this domain? So what we've done is we have created another restriction. No longer can x be greater than or equal to 5. Now x can only be greater than 5. Because you know that the radical didn't go anywhere. I mean, its rule, excuse me. The radical's rule didn't go anywhere. The rules never disappear. So I don't care that the radical and the square cancel each other out. You still have to use both rules. The bottom can't be 0. The inside of a radical can't be negative. But if the radical's on the bottom of the fraction, it also can't be 0. So the new domain, so this is part A, and part B, the new domain is x is strictly greater than 5. You cannot include 5 any longer because the result says you can't have x equals 5. Because if you plugged in 5, you would have a 0 on the bottom. There would be more to it if it was an IB level question. There'd be more to it. Yes, Aaron. You have to say 1. So if it was one question, it would say find g of f of x. You would say, and if it didn't have a part B, you would say 1 over x minus 5, comma, x is greater than 5. You have to include the x is greater than 5 because if you don't, you have a, well, why am I going to describe it? Why don't I just show you? Desmos to the rescue. Seeing math is so much better than saying math. Dr. Desmos. All right, come on. So 1 divided by x minus 5. There is 1 over x minus 5. Here is 1 over x minus 5. It's a rational function that we just talked about yesterday. Now check this out. 1 divided by, set of parentheses, squared. And inside of here, we need a root. Boink. And I want to turn this off. Radical cannot be empty. I'm aware radicals can't be empty. Only half the graph exists. Because the original thing said x had to be greater than or equal to 5. But the moment you put it in the bottom of a fraction, it can no longer be or equal to 5. Because if you put a 5 in there, you get a 0. So I'm aware that it canceled out like this. So if it didn't say A and B, the answer would be this, and you would have to do this, comma, x is greater than 5. And of course, Desmos doesn't understand what I just wrote. So if I want Desmos to understand it, I have to do, whoa, what was that? There. Now Desmos understands it. But you would have just done comma, x is greater than 5. And look, they're the same thing. Pretty cool, huh?
Yeah, that's pretty cool.
Yep. Yeah, he just did that to shut me up. I'm not dumb. Okay, so back to the notes. And you had a question as well.
Oh yeah, so like that was on this IB exam. Do we have to simplify the denominator?
Simplify, yes, because the directions would normally say simplify.
Oh.
But you would have to list the domain restriction. But I would tell you this, though. More than likely, that would be a scaffolded thing where it would say, find f of g of x, or g of f of x in simplest form. And part B would be, write down the domain of g of f of x. And then there would be a part C that did something somewhere. But yeah, they would normally be part of a larger question with several steps. Was that it? Oh, look at that. Cool.